Good morning, third graders, or good afternoon. It's morning here when I'm doing this video. I'm back for another week of remote learning with you, and I am ready to begin our math lessons. So this week you will have two lessons to work on. We're going to be doing lesson 3 and lesson 4 in your Into Math workbook papers that have been sent home. We're going to start with lesson 3. I hope you all have been working really hard and learning lots with all the different activities that I've been sending home for you to do and the different things for you to be doing online. I hope that you are really taking this work seriously and you are working really hard. I know that you are. So just please keep continuing. I know sometimes we can get into a slump, but I know that's not going to happen. We're going to keep working hard. So I would like you to have lesson 3 in front of you. It starts on page 43. I'm going to flip my camera down and then we'll get started. Alrighty. Okay, so we should be on, sorry, page 43. Page 43. And we're going to start with lesson 3. And, oops, sorry, gotta get my camera in a good spot. I always have to slide this around a little bit. I apologize. All right, so we are going to relate area to addition and multiplication. And after this lesson is done, you're going to be able to use repeated addition or multiplication to find the area of a rectangle. I wonder if I turn the lights on, if it will be better for you. There, that's a little brighter. So, Zenda draws 3 designs for a game board. She wants the game board to have an area greater than 12 square centimeters. Which design should Zenda use? So let's think about game boards. Game boards can come in all kinds of different designs, right? And they usually have squares on them, and you jump around with a little game piece, right? So you need to have your game board a certain dimensions, so that way, however you want your game to go, you have the right way that your pieces are, or your squares are laid out. So she has 3 different designs here. And she wants her board to have an area greater than 12 square centimeters. And remember, the area is all the space inside the rectangle. All those squares inside is what the area is. So there's a couple of ways that we could do this. Let's look at design A. Let's count out all of our squares and see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is 10 square centimeters. Is this one big enough? No, it's not big enough. She wants it to have an area greater than 12 square centimeters. I'm going to show you another way we could count them out. So we could first start by counting out all the different squares. Another way is we could count the rows. Remember? So this one has 2 rows, right? 1, 2, and let's see how many are in each row. 1, 2, 3, 4, 5, 6, 7. There are 7 in each row. So if I were to take those 2 rows and I would say, what is 7 plus 7, right? Because each row has the same amount in it, right? This row has 7, this row has 7. We could even write that in if we wanted to. You don't really need to, but if that helps you visually see that we have 2 rows of 7. So if I were to add 7 plus 7, I would get 14 square centimeters. And she wanted a game board to have an area greater than 12 centimeters. So I think we just found the one we want. But I'm going to show you one other way that we could find the area of our game board. This game board, remember how we talked about how there were rows and then how many were in each row? Well, this game board has 3 rows with 1, 2, 3 in each row. So this one, we could multiply. Remember, we talked about this previously in some of our other lessons. So we could say there are 3 rows times 3 in each row. And I know that 3 times 3, I know if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 3 groups of 3. 3 times is 9 square centimeters. So which design would be the one that Zenda would want? Remember, she needs greater than 12. It would be design B. So you can see that there are different ways that we can find the area of our shape, especially as long as we know how much the unit is. Each one of these units are all the same size. Each one is 1 square centimeter. All right, page 44. So now we're going to build some understanding. Let me get my next page up here. All right. So Monty uses unit squares to measure the area of a game card. Each unit square is 1 square inch. He makes the drawings below. What is the area of the game card? So first we have to show 2 ways that we could find the area of the game card. So we want to know, what is the unit measurement that Monty is going to be using? Well, let's look back in our problem. Monty uses unit squares to measure the area of a game card. Each unit square is 1 square inch. So what unit of measurement does Monty use? He uses a square inch. Remember our last problem that we just did, Zenda used square centimeters. Monty is using square inches. So the unit of measurement that Monty is using is a square inch. What methods or operations could we use? Well, let's think about what were all the things that we did for Zenda's. We just counted up all the squares. We counted one row and the second row and we added them together, or we multiplied the rows times how many were in each row. So one way we could do this is I can count the unit squares, or the number of squares there are. I could add, or I can multiply. Whoops. I don't know what I was thinking there. So I can count the unit squares, I can add, or I can multiply. What I'm going to do for my first one, because it wants us to show 2 ways to find the area of the game card. So the first way that I want to show the area of the game card, I think what I'm going to do is I'm going to add for this first one. So let's count how many are in each row. 1, 2, 3, 4, 5, 6. So there are 6 in each row. So how many times am I going to have to add the number 6? I hope you're thinking, or you said out loud, that we need to add it 3 times, because there are 3 times that I added the number 6, or that I counted to 6. So this first one would be 6 plus 6 plus 6, right? I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I have written counting to 6 3 times. So I'm going to add 6 3 times. 6 plus 6 is 12. 12 plus 6 is, I hope you're thinking 18. Wanted to give you a little wait time there to do the work. So we can see that these are exactly the same size, right? So I know my answer is going to be 18 for both of them, but we need to find this in another way. So let's multiply for this one. In order to multiply, I need to figure out how many rows I have. And we already figured that out over here, right? 1, 2, 3. I have 3 rows. And then I also figured out how many were in each row. There are 6 in each row. So if I take, see, I have my 3 6s. If I were to do this in multiplication, I would say 3, because I have 3 rows of 6. So 3 times 6 says I have 3 rows of 6. So 3 times 6 equals 18. And if I were to count all those squares, I would get 18, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So see all the different ways that I can represent how to get to 18 when I know that I have the same size unit, I have the same number in each row, and then how many rows that I have. So what is the area of the game card? The area is 18, but we cannot forget our label. What unit of measurement did Monty use? 18 square, and I'm going to do SQ, and I'm going to do NIN for inches. That's my label, square inches. Sorry. Okay. Page 45. Now we're going to step it on out. So now we're going to work with Tammy. So Tammy uses unit squares to measure the area of a floor mat. Remember, the area is L inside of our shape. Each unit square is 1 square foot. So each one of these equals 1 square foot. What is the area of the mat? So first, we want to use repeated addition. What number do you add each time? How many times do you add the same number? Well, let's think about that. Let's answer the first question first. What number will we add each time? Well, we need to figure out how many are in each row. We have 1, 2, 3, 4, right? 4 in each row. So we're going to add 4. How many times are we going to add 4? Well, how many rows do I have? 1, 2, 3, 4, 5. I have 5 rows. So I'm going to add the number 4 5 times. So I'm going to put a little semicolon in here showing that I'm answering each question or each part of the question. And I want a label here for the 5, so I'm going to add it 5 times. So we can see that we have it started here. We're going to add 4 plus 4 plus 4 plus 4 plus 4. So I have 1, 2, 3, 4, 5 of them. So 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. So that's how I can show it with addition. Now, how could I show the same problem with multiplication? So the first question, how many rows are there? Well, we just figured that out, right? How many rows? 1, 2, 3, 4, 5. There are 5 rows, which means there are 5 feet. How many squares are in each row? We already figured that out up here too, right? 1, 2, 3, 4. There are 4 squares in each row. So that would be 4 feet. Because remember, 1 square equals 1 square foot. So if I'm counting my rows, this would be 1 foot, 2 foot, 3 foot, 4 foot, 5 foot. There are 5 feet. And then how many are in each one? 1 foot, 2 foot, 3 foot, 4 foot. So it's 5 by 4. So there are 4 squares in each row. So now our multiplication. The number of rows, 5, times the number of squares, 4. 5 times 4 equals, what did we find out up here? When we had 5 fours, we have 20. So we're adding 5 4 times. So the area of the mat is 20, and we have to have our label. Remember, we use our unit, 20 square. SQ is the label, or is the abbreviated label, and FT is the abbreviation for foot. So 20 square feet. So let's do some practice, or some more practice, I should say. I'm going to come up here. So we now have Finn. And Finn uses unit squares to measure the area of this figure. What is the area of the figure? We can see here we're going to add first, and then we're going to multiply to find the area. So when we add, we need to figure out what? First, we need to figure out how many squares are in each row. How many squares? 1, 2, 3, 4, 5. There are 5 squares in each row. And I'm going to add my number 5 how many times? Well, how many rows are there? 1, 2, 3. I'm going to add my 5 3 times. 5 plus 5 is 10. 10 plus 5, I hope you said 15, equals 15. So when I multiply, I know I have how many 5s? I have 3 because there are 1, 2, 3 rows. So I'm going to multiply 3 times, and there were 5 in each row. 3 times 5, that equals 15. So my area is 15 square centimeters. All right, and number 2, we're going to do the same thing. We have Avra uses unit squares, to measure the area of this figure. What is the area of the figure? We can see, I'm sorry I didn't point that out in the last one. Each little square for this one equals 1 square centimeter, and that's why the label was square centimeters. Each little square for this one is square inches. So we're going to be looking for square inches. So if we add, how many are in each row? 1, 2, 3, 4, 5, 6, 7. We have 7 in each row. And how many times am I going to have to add 7? Well, I have 2 rows, so that means I have to add 7 2 times because I have 2 groups of 7. 7 plus 7 equals 14. So now to multiply, I know I have how many 7s? I have 2 because there are 2 rows of 7. So 2 times, and in each row there were 7. 2 times 7 equals 14. So my area is 14 square inches. Okay, so we're going to practice just a couple more. Last page. Just a hair. All right, so remember when we get to this part, the on your own, if you want to pause the video, I always think that's a great idea if that's what you want to do, and try these on your own first, and then you can come back and check your answers along with me to make sure that you did them correctly, or you can stay right on here with me and we'll do this together, and then you'll have your homework to practice independently. Okay, so if you want to pause it, go ahead and pause it, and then come back after you finish. Number 3, Muyu, I'm going to guess is her name, uses unit squares to measure the area of a playground. Each unit square is 1 square meter. What is the area of the playground? Well, we could do this in lots of different ways. How about for this one, we just count the squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there are 36 square, and I know my unit of measurement is meters, so I'm just going to use an M. And M is the abbreviation for meters. Or you could write out square meters, whichever way is easier for you. All right, so we're going to find the area of each of these figures. We're going to show the repeated addition, and then we're going to show the multiplication. So for this one, each unit square is 1 square foot. So each one of these is a square foot. So we've got to remember that that will be our label when we get down to the area part. So first we need to add. So I need to figure out how many squares are in each row. There are 1, 2, 3, 4, 5, 6, 7. 7 squares in a row. And how many rows do I have? I have 1, 2, 3 rows. So that means I have to add the number 7 3 times because there are 7 squares in each row. So I have to add 7 3 times. 7 plus 7 is 14. What is 14 plus 7? I hope you said 21. So how many rows of 7 did I have? I had 3 rows. So I had 3 groups of 7. 3 times 7 equals 21. So the area, all the squares covering the inside of this rectangle is 21, and we have square feet. And you can abbreviate it if you would like, or you can spell it all out if you would like. Whatever is easier for you. All right, number 5. Each unit square is 1 square inch. So our label for this one will be square inches. So first we're going to add how many are in each row. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 in each row. And how many rows do I have? I have 2 rows. 8 plus 8 equals 16. So if I multiply this, I know I have 2 rows or 2 groups of 8. So 2 times 8. My 2 groups of 8. My 2 rows of 8. So 2 times 8 equals 16. So my area, all the space inside, all of these little squares inside is 16, and my label would be square inches. So IN is your abbreviation for inch, or again, you could spell it all out if that's easier for you. So number 6, a little word problem here. Dev is measuring a rectangular figure using unit squares. Each unit square is 1 square inch. So far, he has made 2 rows with 7 unit squares in each row. He sees that there will be 4 more rows of 7. How can Dev use multiplication to find the area of the rectangle? Well, Dev said that originally he started with 2 rows, but he can see that there will be 4 more rows of 7. So let's think about how many total rows will he have? He will have 4, 5, 6, right? He has 2 rows, and there's going to be 4 more rows. So he's going to have 6 rows. So he's got 6 rows, and in each row there are 7 units. So how could he solve this problem? Well, they want us to solve it using multiplication. Well, if I have 6 rows with 7 units in each row, I could do 6 times 7. 6 times 7. Well, I'm going to be counting 7 6 times. So if I've got 7, 7 plus 7 equals 14. 14 plus 7 equals 21. 21 plus 7, 28. 28 plus 7, 32. No, sorry, 35. My brain just had a little cramp on me. Sorry, 35. And then 35 plus 7 is 42. So we counted 7 6 times. 1, 2, 3, 4, 5, 6 times. So it will be 42 square inches. Sorry, I'll pop it up a little bit. It's kind of low on the screen. So for your homework that goes along with this module, I would like you to do lesson 2.3, the black and white worksheet that comes directly after this page in your group of papers that I sent home with you. Please do that, and front and back, and either send it into school or take pictures of it and have mom or dad or someone at home text me or email me the pictures, or you could add the pictures on Google Classroom. Alrighty, thanks guys, and I will see you for the next lesson. Bye.